All right, so last time we introduced this idea of quantization. So let's take a look at one of the most popular examples. So we have an atom here, that's our nucleus, and then an electron is floating somewhere around this atom, right? An electron is negative, the nucleus is positive, so there's an attraction here. You can think of two opposite ends of magnets, they're attracted together. If you want to pull them apart, you have to insert energy into them. So you have to add energy to pull apart. So if you were to add energy to the system, this energy could be absorbed by the electron, and then the electron would go further away from the atom, right? So this is called excitation. You excite your electron. And after you excite your electron can relax back down. Not into the nucleus, but kind of to where it was before. So maybe something like that. And so one of the ways to relax here, if you think about a ball falling, it's releasing energy. An electron, there's not really gravity on this scale. So when an electron falls back down, one of the things it can do is release energy in the form of light. So you've got an electron around an atom, you add energy to it, it excites, and then it falls back down. And when it falls back down, it can release light. So let's take a look at whether these electrons' energy levels are continuous or quantized. So on the left here, we'll say a continuous model of an atom. And then on the right side here, we'll say the quantized model of an atom. Right. So if we think about a continuous system here, this electron can be wherever it wants to be. And so we could add varying levels of energy. And so we could raise this electron up to however much we wanted to be, and then it could relax and release some light, right? So the electron can be at any height depending on the energy level. So we could have it be, one height, 1.11 heights, 1.111 heights, or whatever. So electron can be at any height depending on energy added, right? So when it relaxes back down, it can be at any height. And so thus it could release any amount of energy depending on its original height, right? So height's continuous. Right, continuously variable. So this electron should emit all wavelengths of light, because we should be able to excite it any amount that we want, and then it should relax that same amount. So if we want it to emit blue light, we can shoot blue light at it and it'll emit blue light back, green light, red light, whatever. And so if you think about what kind of light spectrum you would get, you get all of the different types of light. Right? This atom would be able to emit any type of light that you wanted it to, depending on how much energy you added. And so you could get the full spectrum of light. The other model of the atom is the quantized one. So again, we have our nucleus in the center, but now we say that this electron here can only be in certain energy levels. It's quantized, only in certain steps. So it can be somewhere on these little orbits that I've drawn, but it can't be in between them. It can't be in between them. So we'll say this electron can only be on certain energy levels. We'll call them orbits or orbitals, right? So this electron can only be on these orbitals. It can't be below or above these orbitals. It can only be on them. And so if we think about when we excite it and then allow it to relax back down, so we excite our electron, and then it comes back down and then releases light. Well, the electron can only be at certain heights. Remember, what we mean by heights here is the distance from the nucleus. And so if it can only be at certain heights, only certain energy changes are allowed, right? And so since this height is quantized, the energy levels emitted are also quantized. And so if these energy levels are quantized, then your atom only has some choices of ways to relax, right? It can relax from like the fourth to the first orbit, but it can't relax from the fourth orbit to the 1.5 orbit, right? It can only land on these orbits. So it can only emit certain wavelengths of light. And these wavelengths of light correspond to these energy changes up here when it's making these quantized transitions. And so if the model or if the atom was quantized, what you would see is something like this, where only certain energy levels are allowed. Right, you can see only some types of wavelengths are allowed, and these again correspond to these energy changes. And so if you look at the spectra of real atoms, this one is reality. This is the correct one. We never see this. And so this tells us that the energy levels in an atom are quantized. The electron cannot be as far away from the nucleus as it wants to be. It has to stay in these things we call these orbitals. These energy levels are quantized. And so a great example of this is kind of a flame test of different elements. So you can put different elements under a flame and they'll emit different colors. And these colors basically correspond to these energy transitions. So there's a cool example. You can see the different elements and their different colors, right? Barium, copper, potassium, all pretty cool. And so this is basically the basics of how fireworks work. Fireworks are basically these elements, and then you shoot them up in the air, you heat them up, so you excite these electrons, and these electrons relax back down, releasing only certain wavelengths of light. So again, the energy levels of light are quantized.